if we are having this particular problem, which is saying us that we need to determine the nodal deflection, reaction forces and stresses for this particular truss system with respect to our geometrical inputs given as our Young's modulus value E is equal to 200 GPa and a cross-sectional area is given over here as 3250 square millimeter. So when we are seeing for this particular numerical, we can see over here our area is given over here in a square millimeter. The length of a member over here is given in a meter. Height is also given in a meter. Loadings are given in a kilonewton. So before going for the solution or before starting our numerical, we must bother about units. So our unit must be in a one system. Whatever we need to follow or whatever we can convert in a easier ways. According to the output required, we need to go for this particularly. So how to solve this particular numerical with respect to the software we are going to see right now. So I minimize it. When we are going for the solution or when we are starting our numerical over here. So we are starting from the preferences in a ANSYS main menu. Set our preferences. We are knowing we need to solve for a structural trusses problem. So we are going to set it as a structural and just say OK. Once our preferences are set, we can go for preprocessor over here. In the preprocessor, we need to go for our element types over here. Say element type. In the element type, we need to add it. How to add it? We are very well familiar with. It is a 2D truss problem. So we should add over here as a link. So say link 2D spar 1. Either we can say directly over here as a 1 and just say OK. We are having our link 1 input over here which we are going to use as an element type for the solution of this particular problem. For the link 1 member, we are having a 2 degrees of freedom as a translation in X and a Y axis. Just close it. Link 1 member is a straight line member which we are going to use over here having two nodes. We can see over here, just go for what will be the representation of that particularly. So when we are going for the link 1 and when we are going for the rest of the elements, we are going to see over here. So link 1 is nothing but a straight line member over here in this ways having a 2 nodes over here, one at a start and one at a end. So a 2 noded 1D element. We can call this particular node over here as an ith node, and for this particular node we can call it as a jth node. So it is over here we can call this particular link 1. Say link 1 element is nothing but over here as a 2 noded element which is having a degrees of freedom ux 2 degrees of freedom. We can say it over here as a 2 degrees of freedom 2 DOF 2 degrees of freedom this particular element is having. Those 2 degrees of freedom are in a x direction. One comes in a ux. U stands for our displacement. One is ux and another is uy over here. So in this way we are having this particular element. The orientation might be vertical, might be on a horizontal ways also. So representation might be anything. We can use over here this particular element in a horizontal ways. We can use this particular element in an inclined manner also. Whatever might be the representation in a xy plane, it is a 2D spar link element. So this will be the description required for this particularly 2 noded having 2 degrees of freedom in a x and a y direction. So how to use this particular element? So minimize over here. We are adding for that one over here as a link 1. Now I need to go for the material real constant or a geometrical inputs related to this particularly. The real constant stands for the geometrical inputs over here. Just single click on a real constant once we are entering our element type. say real constant. Now I need to add it. So when we are going for the trusses problem with respect to the link, we need to go for real constant, say add. Again we are having a new pop-up window over here. Again we should say add. Now we are entering our real constant or the geometrical cross-sectional area and all inputs with respect to the geometry over here. Just say OK again with respect to the link one. Once we are saying OK, now we are having one input over here given as a cross-sectional area 3250 square millimeters. So we need to enter this particularly over here in a real constant. So I'm going to enter over here as a in front of a cross-sectional area 3250. It is a first number set over here. If we are having a different cross sections, so we will enter for 1, 2, 3 in that ways. So we are having only one cross sectional area uniform for this particularly, so we are going to enter that one. Just say OK. Once we are setting over this, we are getting over here as a set 1. If we want to delete, we can delete over here. If we want to edit, we can say edit. With respect to that particular element type, say OK, we are having that number back. So in that ways we need to add for real constant. It will vary according to your element type and according to the geometry applications. So once we are entering for a real constant, now we should go for the next option in a preprocessor is material properties. So what exactly we are going for in a material properties? Say material properties, single click, again we are having a list. Now again we should go for material models. A single click, we are having a new pop-up window for the material behavior. So in this ways we are having two different sub options in a material behavior. One is material models defined and next is material models available. We are having an available models over here. Now we need to go for structural analysis. Just double click over here. We should double click on a structural. Now again we need to enter our material property with respect to this particular numerical as a Young's modulus value. So 200 GPa we are having. Say resonate. Structural double click. Say again double click on our linear. It is a linear numerical. Stress is within elastic limit. Then it's an elastic. Double click. It is an isotropic problem. So again double click on an isotropic over here. Now I need to enter an E value or a Young's modulus value in front of an EX section. Now I am going to enter over here as a 2 GPa. So I am going to enter over here 2E5. PRXY stands for our Poisson's ratio value. For this particular element type we are not needing it, so we are keeping it blank. Once we should enter for 2E5 or 200 into 10 to the power 3. So this particular value comes over here 1, 2, 3, 4 and a 5. In this ways we can represent, otherwise we can say 2E5 and just say OK. Once we are saying OK, we are having one note highlighted here. We haven't entered our Poisson's ratio value, so it is saying over here that it is stated as by default 0.0. Once we are saying OK, it will set all the value whatever we are entering over here in available models over here. Linear isotropic. If we are going for the double click on this particularly, we are having 2E5 over here. We can cross check these values from the material models whatever we are defining. Once we are entering our material property, we should close it. So our material properties are over, element type is over, real constant is also over. Now I should go for the modeling of this particular section. So how to model it? With respect to the given input,